So far, we've been working using vector data, which essentially is data that's referenced, using latitude and longitude coordinates, points, lines, polygons, These are data that we have been working with. And so, as you can see, vector data scales proportionally and it's essentially referenced using these features, But now I want to talk about working with raster data. Raster data is essentially data that is reference using pixels and cells, in image formats, and it's one of the major formats for um, rendering and referencing GIS data. So in a raster, we have this notion of pixels, what we also refers to as cells, So this is essentially what a pixel is. In an image, all right, we have this um, basic units, called a pixel or a cell. And so this essentially is the basic unit of information stored in a raster. And so a raster is essentially this image that brings together these multiple cells into one image, and the cells are used to store information, geographic information acquired from the earth, most of the time using sensors or satellites, And so this is how raster data differs from vector data. In vector data, we're basically working with points, lines, and polygons, which store geographic information as parts of their feature geometry. Raster data, we're not mostly dealing with geometry, we're dealing with pixel information, which also stores uh, geographic coordinates and also the an extent, what's called the cell size. All right, so this raster information, essentially means that the cell, has an extent which translates to a real world extent, So for instance, the real world extent of a cell could be 10 meters, all right, meaning that in this square of 10 meters, if we say an attribute or a value is added to that, cell, then it means in the real world, everywhere within a 10-meter radius, within that 10-meter box, will have that same information attributed to the raster. All right, for instance, we're talking about elevation, and for some satellites moved across the earth and acquired elevation information over the earth, then we can render that elevation information using a raster cell which appends one particular elevation value, for instance 50 meters, to everywhere in the real world within that 10-meter cell extent. And so let's just take a brief look at how raster information looks within a GIS. I'm going to go to the browser. I'm going to bring in a raster elevation, which is called a TIFF file, from our elevation folder. So I'll right click and select add layer to project. Now this brings in this raster layer, into our project. And just like every other layer, it's added to the table of contents. I'm just going to quickly move this to the bottom, and so I'll hide other layers that are not necessary at the moment. And so if I zoom in, you can see that our raster is essentially made up of pixels. Pixels are these tiny little square boxes you see, which essentially are holding one particular unit of information for our raster. And so this is what we refer to as a cell in the raster. So the more cells you have, in a raster, the higher the resolution of the raster, because it means for a unit area in the raster, you could have more information, added to the raster than a raster that had a larger cell but smaller extent. Alright, so where I have more cells per unit area, this essentially means that I can store more elevation information for this case, meaning that I have a greater resolution of information for that particular region. And so just like every other feature we have styled, we can also style our raster layers. So I can come here and select this layer and go to the layer styling panel, alright, which brings that up, and I can see my elevation layer is selected. Now elevation and basically raster data comes with something known as a band, which essentially is the range, okay, of values applicable to the raster, which essentially means that that raster sorry that raster can hold multiple classes of values. So in this case, we only have one band, which is the gray band, which is band 1, which is what is stored, okay, in this raster over here. So our elevation layer is the only current band in this, but there are other rasters that could be used to store information. Some rasters come with multiple bands, like raster layer, which is like Landsat, okay, which is a satellite imagery offered by the US government um, to perform scientific analysis. And so the Landsat data um, comes with at least 7 to 8 bands, which includes some color bands like red, green, okay, blue, and then some other bands like near infrared, and some thermal bands. And so you can see that multiple classes of information could be stored in one unit of raster, okay, and then for that particular extent, multiple kinds of information could be used. And so this is the value of raster data. This is why raster data is useful, because we can't, essentially create vectors for every single feature on the earth. And so sometimes it's more economical and sometimes it's more efficient to store large volumes of information, okay, which is mostly sensed from satellites into about our environment into rasters. And so there are a number of styling themes we can apply to our rasters, which include layer styling themes. So right now we're working with the band 1 gray band, and so there are a number of styling themes currently available in QGIS. I'm just going to start this with this single band pseudo color, which essentially gives a color ramp to the elevation values, okay, as you can see from the lowest to the highest. In the gray band, what we essentially had was two distinct colors, which was black to white, and it essentially gave them a different shade of black to white depending on the values of their elevation. Pseudo color applies a much more colored ramp, okay. There are a number of them. So if I come to this color ramp here, I can select and choose from different color ramps, okay. I can also select more color ramps from here, or create a color ramp depending on how I want my color ramp to be symbolized. And so by doing that, essentially QGIS creates a number of colors, okay, color shading depending on the elevation value of the particular cell, that cell value ranges of the raster. And so there are also a number of modes of symbology, okay, modes of classification of the colors based upon the color ramp. Now this is currently being classified using a continuous color classification, okay, which uses the default ranges of values in the raster. There are also some other kinds of interpolation that are used, like equal interval, which gives us a more robust classification and allows us to see features using the color ramp, okay. The quantile method is also good, which highlights more features, okay, but mostly prefers higher values, okay, than lower values. So I think I'll stick with the equal interval for now. All right, and one thing I can also do is to adjust the transparency of my raster. So I'll come to the second level here and select transparency and change the opacity, okay, down a little. As you can see now, I can see the river features which are lining up with the raster somewhat uh, well, okay. So I can also do that. So if I wanted to maybe perform an analysis that required me to see the elevation features in more detail, I could use quantile, okay, to symbolize that. Alright, so having done this, we can begin to do some basic work using our raster data. Our raster data currently holds our elevation information, and so now we're going to save the project and also use the raster information to do some basic work. But before that, I want to bring in another kind of raster, which is an image raster, which is something that you might also find when working with geospatial data. Okay, so while raster data could also be cell-based and hold information like our elevation data from a satellite, raster data could also refer to GIS data that is held within scanned maps. All right, and so those scanned maps could be paper maps that's scanned, okay, and brought into GIS. So in our raster folder, expand the geology folder, narrow geology, and you see this geology folder that I brought in. Okay, and so add that layer to the project. I'm just going to quickly uncheck the elevation layer. Now I'm not currently seeing the raster layer I brought in, right, because it's essentially a scanned map, all right, which has no current coordinate system applicable to it, and that's why I see this question mark here saying that the layer has no coordinate reference system. So I want to actually get to where the layer is. All right, so I'll right click and select zoom to layer, so it pans me to the region. As you can see, everything I had in my map just occupies this tiny little dot here, and most of the raster is being rendered in the rest of the world, which essentially does not correspond to its actual coordinates. All right, so using that, we can actually see how raster information could be brought in using an image, all right, an image map brought into the GIS. All right, and so to explore georeferencing, what we are going to do is um, to 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 explore how we can work with spatial referencing of scanned maps, okay, so that we can use that to position the maps in their correct locations. All right, so I'm going to bring in a map to explore how we can do that. Okay, so let us apply spatial referencing to this image. And so to do that, we'll use the georeferencer available in QGIS. And so I'll go to layer and select georeferencer. Okay, so the georeferencer essentially is to attach coordinate information to unreferenced data like scan maps, okay, and other kinds of data that require georeferencing. So currently there is no layer being georeferenced in this georeferencer map view. So what I can do is to bring in a raster. All right, so I can bring in our raster, which will essentially require that we browse where our raster is located under our folder. So I go to raster, geology, and bring in the geology image. All right, and then I can now zoom in and explore the raster. So we have I attach this crosshair so I can use that to identify our coordinate locations. All right, so what I can do is to come to so right now my pan tool is being selected. That's why I can move the raster around. So if I want to add, I'm going to add something known as a control point, okay, a ground control point, also known as a GCP. So a ground control point is essentially a value that I'm adding to the raster, okay, that I'm telling QGIS that at this particular cell location, these are the coordinates. And so when I do that all around the raster, QGIS is now able to position this raster image correctly in the map space. So I'll use this add GCP points to do that. So I'll zoom in here and just at the crosshair, I'll place that. Alright, and it will ask me for the coordinates of that location. So let me just quickly add the coordinates for this location. So I'll say 6 space. Okay, I don't need to add second because there is no second there. Or I can also say use 0 for a second. Alright, now it's doing this based on our project coordinate system, so that's why I leave that for now, and I'll click OK. Now the point has been added, and in the GCP table you can also see the information attached to it. This is the source, and this is where it's moving it to. Alright, and so these are the deviations attached based upon the coordinate system transformations. So I'm just going to do that for at least 3 other for a scan map like this that has no distortions. You should have at least 3 GCPs to perform a basic transformation. Now when you're using more complex maps that have complex coordinate systems, you might explore other transformations. Alright, so I'm just going to do that for at least 2 other ground control points. Alright, so I've added my control points, and now I want to perform the georeferencing upon this upon my map. So what I will do first of all is to come to the transformation settings and ensure that I have the right transformation selected. Right now we are working with a scan map, and so it's best for scan maps to use a polynomial 1 transformation. Use a basic transformation for scan maps. So other transformations are higher order transformations that are used for more complex transformations. And so I'll accept this default, alright, and press OK. Alright. Now that the transformation has been selected, I will now go ahead and click Start Georeferencing over here. And so I get a notification saying that the layer was successfully georeferenced. Alright, I can also optionally save these GCP points, okay, so that I can reuse them later on. Okay, so I can save the GCP points if I want. Alright, and then now I'm comfortable closing the georeferencer. Alright, so there's a new raster created, okay, which is called this Nara Geology _ modified, which was created when I clicked Start Georeferencing. So I don't need this orange georeference one anymore. I can now remove it, okay, and then I click this and zoom to where the layer is located. So now you can see my raster has now been positioned accurately in the context of my map, in the accurate coordinate space of the map. Alright, so that's how we can perform transformations on rasters, alright, using the QGIS georeferencer. Alright, so we've discussed transformation on rasters. The one last thing we want to talk about is how we can perform basic analysis on rasters using QGIS. Alright, so we have this raster for elevation. Now what I want to use this raster for is to extract elevation information from our rasters, And so to do that, I would come to raster, okay, select extraction and select contour. And so this pops up. One thing I also do before that is to select a more smaller area. Okay, let's assume you downloaded a bigger raster, say Lancer raster, and you wanted to work with a smaller area. Now what you can do is to create a polygon, okay, covering that smaller area, and also work with that smaller raster. Before that, let's explore how we can contour a raster, and in subsequent videos would perform that using a smaller area. Okay, so I'll go to raster, extraction, contour, and then in the input layer, my the only available raster here is selected. Okay, I can also select this other raster here, which is the one which is our raster scan map. All right, so it's going to require a band information, okay, which should hold information that will be used for the contouring. And then essentially contour lines are lines of equal value in a raster data set. So in this case, they would represent lines of equal elevation. And so I want to ensure that these contour lines are 10 units, okay, apart. Now this contour line is essentially in meters. All right, so that means that each line in the contour will be 10 meters apart. So this is the attribute where the contour values are stored. Okay, it's the elevation attribute. And so right now it's going to save it to a temporary file. So I'm just going to click run, and it contours the map accordingly. And if I zoom in, I can see lines of equal elevation, which also somewhat corresponds to my color ramp as well. And so this temporary column contour line, okay, layer has been added to my map. So I can drag that upward, okay, so I can see that more clearly. All right, so I want to make this contour more permanent. I don't want it to be remain temporary, so I would right click and select make permanent. So I'll store that in our geo package and say contours and click OK. So now it's saving the contour to the geo package. Now I can also give the contour some styling, alright, just as we did. But before that, I'll right click to see the attributes in the contour that was just created. Okay, so we see that elevation field with the various contour values attached. So what I can do is to use those contour values to style and symbolize my map. Alright, so I will make them styled based upon the elevation value. Alright, so I can add a particular value of interest if I want. Okay, or basically classify based on the available values that we have. So I'm just going to do a little bit of editing on these values so that you can have a much more cleaner contour line here. So now I've done some basic styling on our contours. All right, now we have some contour lines and some index contours associated with our map. Okay. One more thing we can then move to do is to perform some um, extraction. Okay, for a more smaller area of study. Okay, for our map. Alright, so in the next video, what we are going to do is to explore how we can perform a geoprocessing operation to give us a much smaller extent, which will be used for subsequent work, okay, in our project.